All right, so in this video, it's going to be a short discussion of step functions and possibly even an odd functions. So what a step function is, you've probably never seen it. They're not that critical or important. Like trig functions are super important, right? Step function, you're not going to see that often, but it is a type of function that we can evaluate. Um, it's not on our list of parent functions, but all it does is that weird notation there, the like brackets there, you see the double brackets? All that really means is just round it down. So it's like everything's happening sort of in a it's really going to make like a staircase. That's why they call it a step function. It's also called, if you're interested, it's called the greatest. This is a long one. The greatest integer not greater than. So simple as this, you just round the number down whenever you put it in there. So it's not like an absolute value. It kind of looks like this. So it's f of x, and then it's like bracket, bracket x, bracket, bracket x plus 1. We are not going to do it that much, but it might be a nice little, a nice little thing to have on there because it's actually pretty simple. So what we're going to do is we're going to evaluate it for these x's. So we'll evaluate it for -1, for 2, and for 3 over 2. And then maybe I'll throw a couple other ones in there. We could throw in like -1.7 and I don't know, 3.4. Okay. So let's look at this and start evaluating. So these are extras. So what we're going to do is we're just going to plug in for x. You're going to like this, I think. I really do. You're going to plug in for x -1. So you're going to have -1 in there. You don't have to write this out because a lot of times you can just kind of like figure this out on your own. But for once, it's nice to show it. What is the greatest integer that's not greater than -1? If you just took -1 and I said round it down, would you do anything? It would just be -1, right? There's no rounding to do, so you just round it down to -1, which is what it is, and this just comes out to 0. So it's -1 plus 1, which is 0. So that's your first answer. So let's just look at it. Let's not write it out every time. If you put 2 in to the greatest integer not greater than, you put a 2 in here, and you round 2 down, there's no rounding to do. 2 just rounds down to 2, right? It's already rounded. So it's just 2 plus 1. It's 3. If you put in 3 halves, that's 1.5. So if you put in the greatest integer not greater than 1.5, that's just a weird way of saying round that down, please. What does that round down to? 1, right? 1. So we have 1 plus 1. Then we add the 1 later, which is 2. Okay. Let's try -1.7. So now we have -1.7 is right here. So we're going to take -1.7. We're going to round that down. What's that going to round down to? Debate on this one. It's -2, right? Because you're rounding it down. You have to go smaller. So it's just going to round down to -2. That's the answer to that, plus 1. So -1. Pretty simple, right? And then the next one, I put 3.4. So it says take 3.4, put it into the greatest integer not greater than, and then add 1. So 3.4, round it down. 3, right? 3 plus 1, 4. That's it. That's a step function. But let me show you just kind of like what it looks like, just so you can kind of like understand why we would ever even care about this. We'll just graph it, okay? So let's just graph it like in a very, very basic sense. I think I put the graph over here somewhere. Excited to show you this cool stuff. Oh yes, very fancy. So there's our graph. You obviously don't have to have a beautiful graph. You can just kind of like sketch it. Sketch means like, just very basic. So we're just going to plot some points. -1, comma 0. Okay. Then we'll plot 2, comma 3. 2, comma 3. Again, you don't have to have it. You don't have to have it exact at all. 1.5 comma 2. So 1.5 and then 2. So right here. Whoops. Right there. I'll use the orange, I guess. Negative 1.7 comma negative 1. Negative 1.7 comma negative 1. Somewhere in here. And then lastly, what did I not use yet? I guess just black, purple. Yeah, purple. 3.4 comma 4. 123.4 comma 4. Do you know what it's going to look like? It's going to look like this. It's going to look like this because, let me go in closer if that's all right, so you can see it better. This green is going to go, and all these numbers are going to round down until 3. And 3 actually is going to be up here, and all these numbers are going to round down until 4 for x. So every number is rounded down. That's why all the answers are just the actual number, right? They're all the same until we change over, until we jump to 5, to 7, to 8, right? So that's why these are holes on the right side and they're dots on the left side. So again, 1 would round down to 1, and then you'd add 1 to it. Hole there, okay? Red goes to here, open. Orange starts here, goes to here, open. And I think you can probably fill in the last one, right? You can imagine where it would be, right? And you can probably see pretty quickly why they call it a step function. And I'm guessing, have you ever seen this before? Probably not, right? No, yeah. And they're not really that important. Like if I was going to cut something, this would be one of those things that could be on the chopping block. Okay, so it's just kind of like, if you think about it in like some terms, there are some ways that the step function makes sense. Like it just stays the same and then it changes, stays the same and then it changes. So it kind of jumps a bunch of times. We actually call this a jump. It's actually called a jump. It's called a discontinuity. So it's like disconnected. Continuity means like you can draw it and never pick up your pencil, but if you have to pick up your pencil, that's a discontinuity. That's what we call that. Even if you had an asymptote, right? If you had another graph with like an asymptote that like kind of came in like this, and then it kind of came in like that, this would also be a discontinuity right here, because you had to pick up your pencil. So that's the basic understanding of continuity. We'll build on that later. That's a step function. So why don't you just try one? I think there's a checkpoint for you here. So why don't you give that a shot? Pause the video if you're watching and give this problem a try. Shouldn't be too bad. So you're just taking it. Now you're going to work the inside first and then do your rounding. I don't know that it matters much, but you'll do the inside first and then do your rounding. So just try it, and hopefully you'll see that on the quiz, because I think it's a nice one, right? In my opinion. That's my thought. So it's the greatest integer or the step function. Okay, and I didn't include it in our parent function, whatever it's called, rules, I guess you could say. I'll talk a little bit about even and odd functions here today too. I should probably pause now. Oh, I don't have my pause button. It's annoying. All right, well, I'm just gonna go through it because I think you're gonna be fine, to be honest. I do want to see where my even and odd graphs are though, so I can get you an example of that. There we go. So if you look at this one, we're just going to add 2 to this number. So I prefer to have this as negative 1.5. I add 2 to it. I have just 0.5. And now I just need to round that down. So my first answer, my negative 1.5, if you will, rounds down to 0 once I add the 2 to it, right? Then I have 1. It rounds down. Well, we add 2 to it, so we have 3. And that's going to round down to 3. And then you have negative 5 over 2. Negative 5 over 2. I like to, again, put that as negative 2.5 plus 2 in the brackets. right? They're a mess too. That's negative 0.5, and we have to round that down. So that has to be negative 1, right? So again, those should be our answers. Okay? That is the greatest function not greater than. All right? So I want to talk to you a little bit about even and odd, and then we'll kind of wrap this section up. We'll do something else with transformations today. Even and odd functions are kind of interesting. I can give you kind of maybe examples of them just to kind of like look at them. And I think if you just look at them for a second, you'll probably be fine. So what I'll do is I'll just kind of show it to you. We're just going to get the idea of it. Even and odd graphs. Okay. So just simply Google it. And if we Google it, we just kind of see like right away that this is an even and odd graph. Okay. So here are 3 graphs. One is even, one is odd, and one is neither. So just visually look at it, okay? The reason that this one's not a great example for neither, but this is not a function really anyways. So I don't even really, actually no, isn't this an even, no, this is an even function. Oh, okay, so they say even, odd, or neither, but this is not even a function. So I don't really like this one personally. I think I'm going to get rid of it. It also doesn't even seem to be correct. So let's ignore that. Let's ignore that completely. So we can just visually look at even and odd. I have issue with what they put there. Okay, so the first graph is even. The reason that it's even is, do you see a lot of symmetry there? A lot of similarity. It's just like a Valentine. You know, when you cut the paper in half and it folds up. It's just like that. Which means that if you go to an x value, like let's say 5, and you go to a y value, let's say this is 5 comma, I don't know, let's say it's 5 comma 4, okay? Let's call this 4. What do you think negative 5's value is going to be? You know it. You can say it. 4, that's right. So if 5 goes to 4, then also negative 5 would go to 4. I don't know exactly where that would be. That is what it is. So it's saying this right here. It's saying if you take the negative version of it, if you make the x negative, you're going to get the same answer, right? So if x was 7 and y was 2, then negative 7 would also go to 2, right? That's all that even is. Odd is kind of the same idea, except like some flipping happened. So what happened was, if you look at this value, let's say right here that this is, let's call this point right here, let's call it 3 comma negative 2, okay? 3 comma negative 2. If that point is 3 comma negative 2, right, what do you think this point is? Thoughts? If it's very symmetrical, if it's perfect. Let's say it is. Yeah. Negative, actually, that would be if it was an inverse. So the inverse would be negative 2 comma 3. This is going to be, what do you think? Anybody? Yeah. Negative 3, 2, exactly. Yep. So if it was inverted, it would be negative 2 comma 3. Yeah, exactly. So slightly different than an inverse. So it's actually negative 3 comma 2. So what we did was, again, we changed the x, correct? And it was the same value, but different sign. Okay? So basically what they did here, if we look at the green circle over there and then we look at the green circle here, it's almost the same thing, except for this, right? So that's an even and an odd function. That's really all it is. You could probably tell me if it's even, odd, or nothing pretty easily. So let's just look at a couple of these and just determine if they're even, odd, or neither. So we have to say even, odd, or neither. And a lot would be neither, but of course we're cherry picking these. So we have this first one, which is 5 minus 3x. We have the second one, which is x to the 4th minus x squared. Whoops. I'm going to show you how to like deal with this a little bit more simple. I mean, it kind of seems less simple, but it's okay. 2x cubed plus 3x. Okay, so let's just talk about this definition of even and odd. So again, even was saying that f of x equals f of negative x. Odd said that f of x equaled, well, not only do we have to put negative x, we actually have negative f of negative x. See what I'm saying? So that's kind of interesting. Now, a lot of people won't write it like that. You might want to have these written down somewhere just in case you don't have them, the green and the red. But another way of saying this, okay, a lot of people will say negative f of x equals f of negative x. That bottom one is kind of more useful when we're like doing these out. So what we can do is actually just, why don't we just figure out what f of negative x is and see if it's the same thing. Does that make sense? Just figure out what f of negative x is. So what we would do with the first one, right? We would say f of negative x is 5 minus 3 times negative x, which is 5 plus 3x. Is that the same as our original or the exact opposite sign? Is that the same as our original or the exact opposite sign? It's neither, right? It's not exact opposite, right? Because of the negative 5. If the 5 was negative, then yeah. But if you think about this, this is a line, and it doesn't really, I don't know, it doesn't really cross through exactly like we want. Make sure I check my answers because I haven't done these in years, to be honest with you. Okay. What is this, 1.5? Okay, cool. Very good. Okay, so neither, because it's not exactly the same or exactly an opposite version, a negative of it, right? So, no. Okay, let's try the next one. We'll change colors. F of negative x, what is it? So if we took f of negative x, right, and we look at this, we have like, I think we have negative x to the fourth minus negative x squared minus 1. So what's negative x to the fourth? Is that x to the fourth? It is. So it's going to be x to the fourth. And then what's negative x squared? That's going to be x squared. So this is going to be negative x squared and minus 1. So this is what we have. Do you see the red? Is it the same as the black? Yeah, it is, right? So this is even. And then we'll do the last one and move it down for you. So all you're really doing is putting a negative in for x and seeing if it's exactly the same or everything changed signs, right? I'll say that one more time. All you're doing is putting a negative in for x, and it's either exactly the same or every sign was changed, or it's not. 3 options. Let's try this last one. I'm guessing it's going to be odd, but I don't know for sure, actually. So if we take it and we put in negative x, f of negative x, that would be 2. That'd be negative x cubed minus plus 3, and that'd be negative x. You see how I just replaced the x's with negative x's? That's all I did. When I take this and cube it, does the sign become now negative? It does. So I have negative 2x cubed, and I have negative 3x. Is this exactly the same as this? No. Is it exactly the same but a different sign? Yes. So it's odd. And it's pretty useful with like graphing. You can graph things faster and understand symmetry and stuff like that. It's not like the most critical thing you'll learn, but it's pretty cool. So again, if I was going to show you the steps, or if I was going to say the steps, I'm not going to write them right now, where we care about these definitions. Basically what we care about is what is this, and if it's exactly the same, right, then it's an even function. What is this, and if it's negative of the original, then that's an odd function. And of course, many will be neither. All right, that's all we have. I will see you guys in the next video. Whoa, I can't believe it was 20 minutes. Okay, bye.